Last stream, a whole week ago, we were working on the Task API. And specifically, we got it set up to talk to Redis. And be able to like put records in there, and maybe that record still exists. I think I have that tool that I installed somewhere. It's not running. Hold on one sec. Redis Insight was the tool that I installed last week so that we could see what was going on inside of Redis. That's coming up. There we go. Yeah, so we had the counter keeping track of the records we were adding, and then the actual task record that was created. So that exists still. We didn't really put anything of significance into the record, just like proof of concept. Hey, we can put stuff into Redis. We're able to talk to it. So I thought kind of the first thing we could do today is kind of just go through the Task API, the list of things that I wanted to do for this, and I think we're just like we're done on these. So setting up the API service with common API lib, obviously that was one of the first things we did, and adding task service to the Docker repos. So that must be in place because we were able to call the API through Postman. Mapping task service API under credit API and Nginx to make it work nicely. Did that. At least I think so. Right, so Control P. Docker compose. Okay, so we have Task API here as a service. And we have Control. Still getting used to this new Moonlander keyboard. What was I going to look for? I wanted to look for where we are storing. Oh yeah, so the Nginx config. There we go. Right, so we're saying that anything that starts with API records tasks gets routed. We strip off API records and just in the like /tasks whatever over to the Task API. So that should make it so that assuming we build the API the right way, our Task API will work nicely with the front end. Part of that is going to be down to how we define the routes in our Task API service. So I think we're just intending to be able to... Oh no, okay, so we did that as well, right? So we defined the tasks route that you can post to create a task. And then we have get, input, and delete routes, HTTP verbs on the tasks/record ID. Of course, we only started working on create handler. We have not implemented any others yet. That is a thing we will want to do. In fact, let me go ahead and just put some to-do markers here. Where is /? There it is. Yeah, there we go. Copilot is going to save me from a lot of typing, which is good and bad. Good in that we'll actually maybe be able to get some stuff done, and bad. Yeah, I guess that is true, but we want to do more than that. Actually, yep. Get the record. You know, give me another. Yeah, return the record. That is what we'll do for the get one handler. And bad because I just need to practice more with the keyboard, right, to get good at it. Let's see, update. We don't want to necessarily. Let's see. Update the record in Redis. Return the updated record. Check. That is what that operation is supposed to do. And then delete the record. No, we don't need to return the deleted record. Return the right status code. So let's see. Practice. So if I want to accept just the first word, I need control and then right arrow, which is that key. There we go. A wild sandal appears in chat. That's right. Since the last one of these coding streams, I added the Pokemon community game. So we have that going on. Return the right G. It is a little painful to get used to a new keyboard layout, but I'll get there. Alright, so some to-dos for things we'll need to do. Some to-dos for the rest of the API. Update the README per the to-do. Okay, so we had a README for the Task API, I guess. I don't know if that got updated. To-do, update this API so it matches what RA data simple REST expects. Okay. I could do that. I'm not exactly excited about doing that right now. Let's see here. I'm going to at least remove the wrong things. And I'll just put to do in there for now. And it escaped, naturally. Yeah. Okay. I think that's as much as I'm going to work on the documentation for this for now. Setting up input-output structs for Task APIs, having API do nothing. Well, I think we did part of that because we had the API that does nothing. In fact, let me pull up Postman. There we go. So we have our Postman really wants to have like a lot of the screen for reasons. There we go. So we were able to post to API records tasks, and we were able to send just the empty JSON body. So we have it, we have the handler in place. But to be able to actually create the task with the details that are relevant, we need to define what that input is. Yeah, so I think this is probably the next thing to do. Or we can shift focus over the task worker. So let me take a step back. So what we last stream, the second half of last stream, we built this Task API. The purpose of the Task API is to be able to queue up work that needs to happen in the background asynchronously, because it may take a while to do. Things like processing, identifying silences in the audio from a video file, or transcribing speech into text from the same video file, those sorts of things. And those things may take, a little bit of time, and it's not something we want to hold up the front end or other tasks, other services, with. So we have this Task API that allows us to say, hey, there's this work that needs to happen. Coordinate this, make this happen. So so that's kind of the background of the what the Task API is for. And then what are we doing with that? Where are we going from there? Well, the Task API handles taking the request for the work to be done and handing that off to Redis to say, hey, here's this work to do. And so that's effectively what we've done here by creating this task record And then the thing we can't see here that we did was using PubSub, right? We published a message with the expectation that a subscriber would see that message and know that, oh, this is their notification that there's this work to be done, right? So who's gonna subscribe for that message? And that's the task worker that's gonna do that. And the idea here is that potentially we could have multiple workers. I guess let me pull up the docs actually, because I wonder if this is actually the right approach. Having said all that out loud, because if we're gonna have potentially multiple workers listening for work, if they're subscribing to the messages, are they all going to get the same message, and would they all do the work? We probably don't want that, right? So subscribe, unsubscribe, and publish. Implement the publish subscribe messaging paradigm where senders, not programmed, characterized into channels. Subscribers express interest in one or more channels. Receive messages that are of interest without knowledge. Decoupling to all the subscribed clients. Subscribers receive the messages in the order the message is published. Right. So this is probably we could still use this. I mean, is there like a more queue-like approach? Let's see, patterns, bulk loading, distributed lock, secondary index, Redis patterns example. Yeah, atomic operations, lists, sets, sorted sets, hashes, data layout. So if there was a different way of doing notifications where we could say, just send one subscriber, pick a subscriber. But that doesn't really make sense because so the difference between a PubSub approach and a queue is that generally there's some mechanism to say, okay, this worker is busy, or this worker is not busy, and so I can go get like the next item from the queue and work on it. Whereas a PubSub pattern is more about, here's a message, send it out to everyone, and everyone that is subscribed is interested in that message. Now, I guess you could have it so that your workers, if they're free, subscribe, and then if they're busy, they unsubscribe, or they get a message, then they unsubscribe, and basically you could probably, with some coordinating logic, implement a queuing solution out of a PubSub thing, but I feel like this is not what I want to do here, right? Because again, we're gonna have these tasks. They're gonna be background tasks. They are going to be something that one process is going to work on and is going to do the work of, and then it'll complete. Or there might be additional work and it might get requeued or something like that. And even describing it, I just used the word queue. That's a hint that maybe this using a publisher and a subscriber is not the right thing to do. So let's just do some Googling here. And I have to type some more. Redis. Redis. Queue. What is this? Yeah, it explains what a queue is. Good for it. Okay, so we could have so what does L push do? list something, list push. Inserts all the specified values at the head of the list stored at key. Okay, so we use a list to represent a queue. And then rpop. Oh, maybe L doesn't stand for list here, it stands for left. And then rpop is removing an item from the right. From the tail of the list, whereas L push adds something to the head of the list, so it adds it to the front, in other words, because a list has a head and a tail. Where well, that's interesting. Returns the element at the tail of the list. This treats the word tail as referring to the last element. You could also think of a tail of a list as being everything except for the head. As in, imagine a snake. A snake has a head, and the rest of the body, I guess you could call a tail. Anyway. Reliable queues. In a basic queue, if a consumer crashes after dequeuing a task, but before processing the task is lost, to prevent such data loss, provides a pattern for reliable queues. That's probably a good idea. Let's check this out. In a reliable queue. Is this text legible, by the way? I could probably make it larger. So let me look at screen preview. Oh, where'd it go? Somewhat. Let's make it a little bit bigger. And can I get rid of the ebook pop-up? There we go. All right. In a reliable queue, a task is not removed from the queue immediately when it is dequeued. Instead, instead it is moved to a temporary queue where it is stored until the consumer confirms the task has been processed. So we use the rpop L push command to atomically remove a task from the main queue and add it to the temporary queue. So to do that, every worker would need to have its own temporary queue. They use the word consumer here, right? So, but we're talking about the same thing that I'm referring to here, the task worker service. So the idea would be, and that we would have one or more, well, I guess technically 0 or more task workers that we could be running in the background that would be looking for new tasks to do, so that this could be scaled up to any number of, volume of things to do. And then our Task API is kind of the gatekeeper, bringing in the work and then putting it into our queue, and then the task worker will take items off the queue. Okay. So I think what I want to do is let's implement the task worker service. We'll implement that using this approach documented here in the Redis docs. And then we'll go back and we'll modify the Task API then to play nicely with that. That'll be good because we should be able to test this out by just setting up everything in Redis manually and then invoking just set up all the data in Redis manually, and then the task worker will see our fake task and do the work, and then we can see that happen. And so we can test that independently, and then we can go back and work on the Task API and fix it up to make it work nicely with this new thing. And then we can complete the rest of the OWL. We can then finish the other endpoints for the Task API, and then go back to our front end and make it possible to actually manually define tasks or in-queue tasks through the Task API in the front end. Again, that's not really the use case that we're trying to ultimately address, because the goal is to have the other microservices, like the silence detection API, call the Task API to queue stuff up. So, all right, so we're gonna make a new thing, a task worker. Save the plans there, and let me fold up all of these other things and go away. There you go. All right, and we're gonna make a new folder, and this is gonna be task tark. Yeah, task. Where is underscore on this keyboard? Is it buried in a layer? It is this one. Aha. Worker. Call it that. There we go. Now it can be next to Task API. And this is going to need. I'm just gonna keep. I could do things in other programming languages, but we already got stuff going in Rust, so I'll just keep on going in Rust. So we're gonna have a cargo.toml, a cargo. Oh, I did it again. Oh, let's see. If I was a right arrow key, where would I be? So on my other screen, I have a thing that shows me all of the different layers for the keyboard to help me navigate this thing, because it's a lot. Cargo dot TOH no ML. There we go. SRC. There we go. And a main.rs. Okay. And unlike all the other little microservice things we've built, where we have we're using common API lib, I think in this case we're not going to. This is not a web service. It's not gonna accept HTTP requests or any of that. I'm gonna start with this, and we'll cut out things that we don't need for our task worker. Right, so we're not going to need common API lib, so that's gonna go away. We don't need Axum. Will we need Surdy? I'm gonna say no for now. Potentially we might end up in a situation where we are like dumping JSON into Redis that we're then reading out of, but let's assume for now that instead that in the task, well, is there going to be a task record? I think there's still going to be a task record. We're going to have a queue that's going to have like the message identifying the task that we're working on. And then that identifier will be the key, right, to where the actual task record is. That's going to have all the details about the task. That'll keep our queue really simple. It'll just be like a list of strings. But that task record, because it's a hash in Redis, so it's just a set of keys and values, I don't think we will need to like nest things inside of that. I don't know if we'll need any of these things. I'm gonna take these all out for now, and we can always add them back if we end up needing that. Hopefully we won't need regular expressions in this. We'll keep tracing in Redis, and we're using asynchronous I/O with Tokyo, so we'll see how that goes. O-R-K-E-R. All right. So, snooze. That is annoying. I was really hoping I would be able to make it all the way to the first break before having to run ads to keep the pre-roll ads from going. That is annoying. Okay, well anyway. Distractions aside. Right, so I was going to look at one of our other main.rs files to figure out how we are defining main here. So we're using this macro from Tokyo. And I'm going to try to see if I can just copy this over here. And so we have an interesting thing, but this is not right. This is like Copilot sees that every other main.rs is using common API lib and all this stuff, and it's just trying to complete the sequence here. But so symbol somewhere I have. There we go. Yeah, let's start with that. That'd be great. If we could just get a hello world, that would be good. All right, and then given that, we need to go into our Docker Compose and add this record. Shift tab back, and we'll do task. Yeah, so is this right? Let's see. So this part is right. We're using our Rust Docker file to build, and we're telling it the service name is task worker. That'll tell it that this is the right folder. We're pointing it to Redis. We're not going to have a health check. Yeah, is there a way to do a health check for this, given that we're not exposing HTTP API? I don't know, but definitely not that one. So, things that we're eventually going to want to pass in as environment variables are going to be a key that's going to identify our queue. QUEU. Okay, so let's imagine that we'll have a key in Redis called Task Queue that will be our list that has all of the tasks to be processed. Okay, so if I save this. Is there anything else I need to do? We probably right now want to just have this. Okay, well we can get the Redis connection, I guess, since Copilot has handily given us that. And then let's just wait for a task to be added to the queue. Sure. Let's see if it actually does that. Nope. I think what I'll do instead is just for right now is wait. Yep, this is my typing speed now. It's kind of sad, but can we just do that? Okay. So now we should have a thing that will print a hello world and just loop forever, so that we can actually see this thing working. And then we'll come back and actually do more. I guess it also will establish that connection to Redis for what that's worth. It is looking for the right var, right? Redis URL. And we are just returning from the function, which is how we're going to handle any kind of failure. We're just going to exit the process. Okay, so, haha, that's that's good. Let's see here. Where would I find arrow keys? There we go. Docker compose up-d build. That looks right. Okay, we don't need the file. All right. So, while we're waiting for this, how are we doing this this fine Sunday morning? Who is lurking? Users in chat. I see a couple people I know, and some names I don't. Hope we're all doing good. I'm going to... So what I have been thinking about doing, now that I'm an affiliate and I have this whole like ad thing going on that I can actually control, I think what I want to aim to do is to take a break every hour, and then we'll roll ads during that break. I'm not sure how well that is going to actually work in practice, but yeah. In the meantime, I now have channel points and emotes. I think there are some follower emotes as well. Those are... Wait, which ones did I make follower emotes? Hold on. Viewer rewards, emotes. There's some kind of like vanilla ones that were like kind of the standard ones that are just like color schemed. Yeah, so I made so we have like a hi and a hype and a GG and a love and a lol follower emotes, and then there's some sub emotes as well that I generated using Dolly through ChatGPT. So we got a couple of not completely terrible ones. Yo. Hey, Foxy Blue. There you go. Exactly. How's it going? My one and only subscriber. All right, so we need to return a result or an option in our main function. Yeah, they are. They're pretty cute. It's really hard to tell because they're so small. But the full size versions of those, you can see the little chibi Miis are wearing little spacesuits. Sleepy right now. You stayed up all night working and stuff. Yeah, I was working on these emotes yesterday while I was hanging out in Marxie's stream. All right, so we are 42 minutes in. Okay. All right, so in about 7 minutes, I'm gonna take a break because these ads are gonna have to run. But yeah, why? Cool. All right. Anyway, right. So if we're gonna return an error, although I don't know why we're returning. Why did Copilot give us this? Why can't we return just like this? And then we'll do... Can we do this? So I'm not getting it. Oh, right. So important thing, in order to be able to actually see things, if you're doing like a monorepo approach like this, where you have multiple services, the top level cargo toml that I've created here, we have to put our project in. So that is not where. There it is. Task schedule API. That's a good guess. Copilot. Where is the symbol for underscore? It's right there. Worker. O-R-K-E-R. Haha. Control S. Yes, new keyboard. Every character stroke is a struggle. Alright. Object traits must include dyn keyword. Interesting. What if we... Right, so we're saying that we're going to return something on error that has the trait of an error. And that's why it's saying this, I think. Control S, see if that's happy. Nope. Still not happy. Can't be known. Yeah, I'm not going to do all that. So we'll just say, what if in the error case we return something else? Like, can we just return a unit type on error as well? Is that allowed? Right, then we have to do... That's not the right thing. ST. Question couldn't convert the error to a unit. Yeah, so the question mark here is used to like essentially say if this results in an error, we can still we can call this, except it won't call it. It will just propagate the error through the result. Used to decide whether the operator should produce a value or propagate value back to caller. How do we do this in a way that... So here's something fun we can try. So we go to quick fix and we say fix using Copilot. Let's see what it comes up with. Okay. So it changed back to box 9. So I guess the box is there because then it takes care of the other error we saw where it was like it didn't have the sized trait. So we'll put that back. All right, Control S, and then remove this bit and we'll accept that. Right, and then we have a warning because we're not using con. Fortunately, that's not going to keep things from compiling, and hopefully now, if I rerun this, if I remember what key is up arrow, there we go, enter. Fingers crossed that this works. We'll be able to go into the Docker, this thing. I thought it did update. I guess I clicked update, but it needed a restart. I'm not going to do that now. Let's go back. So we'll see a new task worker here at some point. Assuming this, yeah, it looks like it built. So we should see that soon. So let's see this working, and this will be good timing because I'm gonna have to run an ad break. So we'll do this and we'll take a little break, and it's also probably good to have shorter videos on YouTube, so it all is all to the good. All right, so did we see in the Docker task worker, we see hello world, and it is running. It didn't stop. So I'll count that as a success. So that means it did print, it did connect to Redis, and it looped forever, and I think it still is running. All right, so with that, we're gonna take a quick break. I'm going to get some water because all I've had today is coffee, and when we get back, work more on the task worker. BRB.